and Antoine Pevsner were Russian-born sculptors who are considered pioneers of constructivism in the 20th century. In 1920, they jointly published Realistic Manifesto, advocating the perceptions of the world through forms of space and time. We affirm the line only as the direction of static forces that are hidden in the objects and of their rhythm. Thus, they bring back to sculpture the line as a direction, and in it they affirm depth as one form of space. We begin our material agency exercises by analyzing pieces in the linear construction in space series. We chose to analyze the linear construction in space in the developable column constructed in 1942.
The developable column was a result of taking the topology of a cylinder and moving the rail curves of the circles contained with the geometrical net of the column, then reconnecting the original points that created the shaft of the column back together. The result became a hyperbolic funnel, appearing as a cone spiraling, but in reality was created through a relocation of the original points and straight lines connecting the point couples. The key features included a twisted conic section and two flares. In the projection into space after accessing more pictures, we found the topology of the cone in the center of the sculpture. When transposing our model into the styrofoam solid block, the main hole of the sculpture made it impossible to cut our model as one whole piece. On the other hand, to articulate the surfaces as a volume, we used negative part of the sculpture for cutting. The intersecting edges and ruled surfaces made it difficult to construct clear tooling with the wire cutter. Choosing the piece that best represented our scene and image and our combined elements was found by identifying clear depths of shadow and volume. Cutting our volumes expressed the natural lighting and depth each geometric foam block could capture. After we finished modeling these ruled surface forms, we were able to extract certain fundamental logic and signature of the geometry into an element. We found that the openness of the Pevsner sculpture shapes was accentuated by this radial line, which, similar to our volumes, created a clear guide for the wire cutter to construct ruled surfaces.
When we transpose the projection into space, the coherence and hidden linearity of the sculpture was misdirected by the coherent surfaces that were placed as volumes within the image. This allowed a derivation process, which is to simplify the edges and produce self-intersection of surfaces. We solve this by decomposing the volume surfaces as always two sets of ruled surfaces to guide the tooling. Transposing the developable column also presents us with challenges such as intersecting cuts and finding distinct fissures and peaks. After analyzing and reproducing elements of the sculptures, for instance, cone, cylindrical topology, tooling paths, jack lines, and shadow, we started fitting these images of elements that were latent space into the neural network. We generated an output by using GAN to formulate continuous interaction towards a hybridized composition. We fed images of the elements into a neural network to construct blueprints from innovative spatial interactions by creating digital models with distinct visual characteristics.
For the realization of our chosen geometry in high-density styrofoam, we prototyped with PLA and we designed a 3D print for our full-size prototype. We used a large-scale hotwire and effector articulated by a 6-axis robotic arm. The main challenge we faced in moving the single sculpture forward digitally was figuring out how to connect the sculpture's rails to the generation logic of the surface. To advance the entire ceiling, it is required to carefully consider the connection issue and the depth variance between the various surfaces. Additionally, tooling is entirely consistent because there isn't a complicated border combination as the sculpture develops. However, the depth and breadth of surface may alter in the overall design of the ceiling, changing the rail of the surface and consequently the tool path for a single rail. It is essential to think about how to divide a rail into segments and fit a tool path while maintaining the design's original contour. Additionally, by altering the tool path orientation to establish a rough boundary, the tooling is locked together from various angles. When it comes to the fabrication, sculpture is consistent surface that can essentially be cut continually. However, the entire prototype must be cut during the cutting process in accordance with the surface characteristics of the tooling. We need to adjust to regulate the lead-in and lead-out of the hotwire cutting. The cutting of various sections in order to maintain the integrity of the connecting tooling. The block may also need to be rotated while some pieces are being cut.
Dema's customization embedded in his robotic fabrication technique gave us opportunity to start our journey from monotonous to distinctive and perceivable sealing. We had the chance to get rid of modern standardization and parametric lattice gradients by creating unpredictable sealing on the basis of height, shape details, smoothness, tooling lines, and curvatures. We designed a multitude of edge conditions with a form shaped like bubbles. The claws were to the center of each hole within the steering, the heavier the tooling pass. This kind of rhythmicity is combined with the lightening the holes of epsilon to grab the audience's attention toward the shapes, peaks, and heights values of epsilon. The potential to set small spatial organization is one of the functional features of epsilon. You will experience this ceiling as a creature growing up and reproducing itself at the same time. The convex and concave forms in our ceiling creates a context of acoustic and lighting features. The differences of height you will experience during our ceilings makes you feel the flow and motion that doesn't end as the ceiling piece meets the wall. We strategically didn't touch the wall to create a stream of continuous motion. This distinctive experience using technological reproduction and fabrication are what allow us to design this architectural ceiling proposal. How we can use this creative ability in a variety of ways in design. We could generate interior fixtures, furniture, double-layer facades, decor, even jewelry and accessories. All in all, we've now practiced how to look at architectural elements in different ways, such as column, ceiling, wall, and etc., and to redefine them towards another creative direction. Tefts and the Bull used the lines of frame direction and pattern of form in 1990. Now, 100 years later, with the implementation of AI collaboration and robotic fabrication, we're able to tailor to less formal variability by perceiving each piece differently through unfolding various depths, thoughts, and testing our imagination.